Hello and welcome to The Right Angle. This is a channel for those children in middle school who are just getting to grips with real mathematics, algebra and geometry, and they're finding things a little difficult. But no matter, you've come to the right place. As you know, we've been doing some algebra, that of expressions. We've been teaching one of the core topics in algebra, and that's algebraic expressions. So we're going to do one special problem today, and it looks initially a bit horrible, but not to worry. Suppose you were asked to multiply 1 plus x into x square minus 2x plus 1. We did it the last time and we came up with an answer that if you actually do the multiplication, and you can see it in the previous video, it comes to be x cubed minus x square minus x plus 1. One of the things I mentioned is that when you have two expressions, for now let's take there's only something like x and numbers, there is no y or z or some other letter. When you have two expressions you're multiplying, the highest order power, that is the power in this expression, the highest is 2 and the highest here is 1. So after multiplying, you should normally see x into x square is x cubed. So the power, the exponent between x, for x and x square, is 1 and 2 respectively. So when you multiply them, you get x cubed. So you should see an x cubed. Sometimes you don't because they cancel out in some way. But that's, just wait a little bit for that. So we got this kind of answer, and you can see that there is some nice pattern to it. There's an x cube and it ends with a 1, and in between you have minus x squared minus x. So the first term and the last term have a plus sign, the terms in between have a minus sign. So there is a kind of pattern to it. Let's take a different problem this time. Let's multiply x minus 1 into 1 plus x square plus x cube. Now some of you in younger classes will look at something like this and say, oh, this is too much. It's too much of work, or this is too confusing. Whenever you see something like this, the first thing you have to tell yourself is, it will not be that difficult. Usually it is not. You just have to attack the problem. Otherwise, problems attack you. So, if you attack the problem, what do we do when we multiply? Every term in one expression is multiplied in turn by each term in the other expression, and then depending on whether there's a plus sign or maybe a minus sign, you add or multiply, or subtract those terms. Here we have this with 2 terms, and here we have 4 terms here. So it is maybe easier to multiply this with x and then multiply this with minus 1 and then add everything, or multiply this with 1 and subtract from the previous, that is, to make it clear. So x needs to multiply this. So you get something when you multiply, and then from that you have to subtract 1 into the full second term. Okay, so let's give it a shot. Do you think you can guess the answer or what it might look like? Let's see, don't trouble yourself too much. X into this is x into 1 is x, x plus into x is x square, so there's a plus, x square, x into x square is x cube, and x into x to the power 3 is x to the power 4. So far so good. And then minus 1 into 1 is minus 1, minus 1 into x is minus x square minus x cube. So this into this will be equal to this. Beautiful. Now it so happens that there's an x here and there's minus x, so they get cancelled out. There's an x square and there's an x square there, so these get cancelled out. X cube and minus x cube, they get cancelled out. And all you're left with is x to the power 4 minus 1. That is this part here. So after all this work, you get x to the power 4 minus 1. As I had said earlier, you have two expressions. The highest exponent in each of those expressions, when you multiply in the result, you must see a multiplication of these highest exponent. So here it's x, or it's also sometimes called the order, x and x cube. So you should see an x to the power 4, and we do. What about the others? You maybe should see x and x square, and then maybe x into x square, which is x cube and x cube. But they all happen to get cancelled out. So you just have x to the power 4 minus 1. The other quick thing is, let's check if this answer is actually correct. So let's put x equal to 2. Okay, let's put x equal to 1. If you put x equal to 1, it's easy, because if x is 1, this is 1 minus 1 is 0, so the entire thing is 0. And x to the power 4, 1 to the power 4 is 1, 1 minus 1 is 0. But a 1 is not a very good check, so you should use some other number, simple number. So let's say you put x equal to 2. So this 2 minus 1 is 1, and here it is 1 plus 2 plus 4 plus 8. What is that? 1 plus 2 plus 4 plus 8. So that is 3 plus 4 is 7, 7 plus 8 is, how much is 7 plus 8 is 15. And x to the power 4, so 2 to the power 4 is 16, 16 minus 1 is 15. So this is absolutely right. So from such a big expression, sometimes you derive a beautiful, simple result. Well, about last time's problem, let's take a quick look. If you look at this, I will be teaching this later in terms of more expressions and equalities. This actually is nothing but x minus 1 whole square. That is x minus 1 into x minus 1. So this, if you multiply, you get x square minus x, then minus 1 into x is minus x, minus 1 into minus 1 is plus 1. So that is x square minus 2x plus 1. So what's happening is you're multiplying x minus 1 whole square into 1 plus x. That is what is happening. And it so happens the result of that is this. Here you have a fairly long expression. But how many terms were we thinking of getting? We were initially thinking of saying there are 2 terms here and 3 terms there. So 2 into 3 is 6. We should get 6 terms. Yes, but there is some cancellations. So we actually end up getting 4 terms. And that's okay. So I hope you like this. So I will take up a slightly more complicated, in a different way, complicated expression in the next little problem that we do. And that will illustrate some other things about how to deal with algebraic expressions. I hope you enjoyed it. Don't forget to like and see you soon.